So this is our code overview of our lab 3. So the first portion we're going to talk about is the music portion that plays a song when the answer is inputted as correct. So this module is called music, and it has a clock, a reset, and a speaker. And it calls the full note is the note we want to chop up to get the actual individual notes that we will do later. And we have a function called divide by 12, which, since there are 12 notes in an octave, it chops up the full note by 12 to get the individual notes that we want to play in the song. And we have a case statement here so that we can get all the individual notes in an octave, and it goes from A to G sharp. And this number 511 is gotten from it being a 9-bit binary variable. And then in this divide by 12, this is where we chop up the full note to get the individual notes in the octave that we want. And in the music ROM module, this is where the actual song and timing is created. So we have an 8-bit input address, we have a clock, and we have an output register 8-bit note. So every time a case is increased, we put in 22, which is one of the beginning frequencies that we want. And we keep it at 22 because we want a simple tune consisting of only 3 notes, and it goes first up and then down. So we have 22 for about 10 cases, and then it goes to 25, which increases the frequency, causing a higher note. And then for another 10 cases, it'll be an even higher note at frequency 27, and then it goes back to 25 and then 22, which gives you the tune that we want. And in the case of 0, we want it to be silent because we don't want the song to keep playing, and then this is how we achieve the note and song that we want. And now Luca will talk about our VGA system.
So for VGA display, we have 2 modules. The first one is called top. It has an input clock, reset button, and 2 wires to sync the output, and then 3 values for the RGB values, so green, red, green, and blue. Then we call the other module, which is the VGA controller, which we'll describe later. But this module just describes the shapes that need to be displayed on the screen based on the pixels that are chosen. So we have this first part displays a red frowny face, and the second part displays a green smiley face. Then in our second module, we have, so this first part, we set the boundaries of the screens, including the front porch and the back porch, both for the horizontal and the vertical directions. And then for RFPGA, the screen syncs when the voltage is low, and therefore this line of code just flips that on and off in order to sync the screen. And this next 2 lines, they ensure that the boundaries are always within the active pixels and not on the front or back porch. And the next always block goes over. So so if the reset button is hit, then both the vertical and horizontal values go to 0, so they get reset. And then if the horizontal count equals to the limit, so the end of the horizontal line, the horizontal is put back to 0, and the vertical count increases by 1. So essentially, you go to the next line. And otherwise, if it's not at the limit, you increase the horizontal count but keep the vertical count the same. So you move horizontally but not vertically. And if the vertical count hits the limit, you reset that to the top.
So this is a demo of our Lab 3 where we built onto our Lab 2 calc and made a calculator game where the user inputs their answer using a push button, and based on their answer, it compares it to the actual correct answer calculated by the ALU, and if it's correct, there's going to be a green screen that appears with a song being played, and if there's a wrong answer, a red smiley face will appear on the screen and there will be no sound. So now we are going to demo it.
Okay, so first we're going to show that some functions from Lab 2 still work. The first 4 buttons are still the input mode, the next 4 are input A, the next 4 are input B. Then we have CN. This is the mode to confirm your answer when you're playing the game. This is to play the game mode. And the next one is to show your answer on the 7-segment display. So you can, mode 4 is addition. You can do 4. Number A can be 3, B can be 3 as well. So 3 plus 3 is 6. That's from our Lab 2. You can also show mode 8, which is multiplication. You can do 2 times 6, which is 12. Okay, this is our addition for Lab 3. We can put the calculator into addition mode, which is 4. Number A to be 3, number B to be 1. Put into game mode. 1, 2, 3, 4. That's our answer.
As you can see, there was a green screen and also a sound played when the answer the user inputted was correct.
Okay, the sound will keep playing if the answer is still correct, but we can input a wrong answer by just hitting the button 2 more times, which means that the result will now be 6 because it remembers the value we inputted before. So we bring that down, and now it shows a red face, and the sound doesn't play anymore. Now we can try multiplication mode, which is mode number 8. We do 3 times 3, put into game mode. 1, 2, 3, 4, 5, 6, 7, 8, 9. It played a sound and showed a smiley face. And then if we make it 10, it's wrong. Yep, it showed a red face.
So this is our 1-minute discussion of our failures and successes in our Lab 3. So our initial plan was to have the calculator input game, which we do have. We had to change a couple parts in the video and audio parts of our Lab 3. So initially we had that if a user inputted a correct answer, it would be an entire green screen, and if the answer was wrong, it would be an entire red screen. And there would be a high sound if the answer was right and a low sound if the answer was wrong. However, we did have a couple issues with that, and Luca will talk about the video component.
So as Jamie mentioned, we're initially supposed to show an entire green screen or entire red screen, and however, when we tried doing this, we ran into issues because a left portion of the screen remained black and did not turn on. We later learned that this was due to us not flipping between an on and off state, but we didn't initially know that, so we decided to display a red and a green face in order to bypass the issue because our faces did not take up the entire screen.
And with the audio component, we were having a lot of trouble toggling between the frequencies, and when we changed certain numbers on the clock, it wouldn't change the frequency low enough to be distinguishable between the 2 frequencies. So we resorted to only having a song. We had a lot of trouble figuring out the song, but we eventually found that with a case statement, we could make it so the timing was correct and make it play at certain times and at certain frequencies.